next part of section 1.4 in our workbook refers to frequency, relative frequency, and cumulative relative frequency. In terms of our book, the OpenStax book has that chapter in section 1.3. And if you scroll beyond the levels of measurement, then you will get into the frequencies. And the Lumen Intro to Statistics with Corequisite has an additional link after the levels of measurement in Module 1 titled Frequency and Frequency Tables. Now, a frequency is the number of times a particular data value occurs, and the sum of the values in the frequency column has to equal the sample size or the population size if you have managed to survey the whole population. So it will be n or uppercase N. And the sum uses the sigma notation. So the sum of the values of the data values x will equal the sum of the data values. And the sum of f will equal the sum of the frequencies and that has to equal n, either lowercase if that's a sample or uppercase if that's the population. So when you collect data, for example, we have here 20 students who were asked how many hours they worked per day, and their responses in hours were this raw data. Raw data is the data as it comes in from a survey. Then we want to create a table of frequencies that is called the frequency distribution. So the table will list the data values in ascending order and their frequencies. And X is the question we asked, which is the hours of work per day. And the frequency will be the number of students who responded that particular number. So this will be the number of observational units of students, the number of elements in the set that was surveyed that gave that particular answer. And 2 hours was an answer produced by 3 students, and therefore the frequency for the variable value 2 hours of work per day was 3, because 3 students replied that. Now, 3 hours per day was answered by 1, 2, 3, 4, 5 students, so that will be the frequency. And 4 hours per week had a frequency of 3 students responding, 5 had a frequency of 6, 6 had a frequency of 2, and 7 had a frequency of 1. The sum happened to be equal to 20. That also is a way for me to verify that I have included all my data. Now, a relative frequency is the ratio, fraction, or proportion, that's what a ratio means, of the number of times a data value occurs in the set of all outcomes to the total number of outcomes. So it's a ratio from the number of times it occurs to the total number of outcomes. To find the relative frequencies, we divide every frequency by the total number of students. In our case, it's 20. The relative frequency can be written as a fraction, a decimal, or a percent. As a fraction, the relative frequency, which will be the percent of students in each category, in each value of the variable. So 3 out of 20, that will be the fraction. If I write it as a decimal and I do the math in my calculator, it will be 0.15. That will be the decimal. And as a percentage, 15%. 5 out of 20 will be the relative frequency as a fraction for 3 hours of work per day, which is 25% or 0.25. So try to pause the video and do the rest of the relative frequencies on your own. Then add the relative frequencies to see what the total should be. So if you have done the math correctly, the sum of the relative frequencies should be 20 out of 20, or 1 as a decimal, or 100% as a percentage. Now, the cumulative relative frequency is the percent. So it is a relative frequency, so it is a percent, but it is cumulative. And cumulative means that at any given level, let's say I'm in this level, the percent will be all the percentages at that level or before that level. Now, what does that mean? The cumulative relative frequency for X will equal to 5 hours of work per day, will equal to the percent of students who work 5, 4, 3, or 2 hours per day. If I am at the level of 7, it will be the percent of students who work 7, 6, 5, 4, 3, or 2 hours of work per day. So this is the percent of students who work at most, meaning equal or less, hours of work at that level, right? At most, this many hours per day. So that's what a cumulative frequency is. A cumulative frequency is a cumulatively relative frequency is the percent of the sample that has that specific value of the variable or less. For this reason, the values of the variable need to be listed in ascending order. So the ascending order is essential if we want to do cumulative calculations of probabilities, proportions, relative frequencies, which is a very common thing in statistics to be done. So how do we find the cumulative relative frequency? We can use the relative frequency column that we found and then just add the percentages as they go down the line. So the first one, which is 15%, 15% of the sample works 2 hours a day, but also 15% of the sample works 2 or less hours a day. To get to 3 hours a day, I will add 15% and 25%. That will be 40% of the sample. 40% of the sample works 3 or less hours a day, which is 3 or 2. Now, for 4 hours a day, I'm going to add 2, 3, and 4, because I'm looking for what percentage of the sample works 4 or less hours a day. So 40 plus 15 will be 55%. And then for 5 hours a day, 55 I have added so far, plus 30 will be 85%. And for 6 or less hours per day, it will be 95%. I will just add the 10% to what I have already calculated so far, and plus 5 will be 100%. Now, that's a good indication that my calculation of cumulative relative frequencies is correct, since at the largest value of work hours per day, my whole sample has now been included. At the maximum value of the variable, I have included the fraction. So cumulative relative frequency is the accumulation of the previous relative frequencies. To find the cumulative relative frequencies, we add all the previous relative frequencies to the relative frequency for the current row, as shown in the table. This requires that data values are considered in ascending order. Now, if you had to round, unlike our particular example where all the divisions of these fractional relative frequencies ended up giving us exact decimal answers, if you have to round your decimal answers and percentages, then you may not have a sum of relative frequencies equal to 1. It may not equal to 1. And the last cumulative relative frequency is possible to not equal to 1. Remember, 1 is also 100%. So because of rounding, it is possible. However, it could be very close to 1. We have another example here in our notes, and this is question 4 of project 1 for unit 1 of our OER statistics course. And the table shows the height in inches of 100 soccer players. So we have to complete the table, and you should pause the video now and either watch the video for question 4 project 1 or try yourselves to identify what is the variable and what are the units of measure, what does frequency mean, what does relative frequency mean, and what does cumulative relative frequency mean. Also, instead of doing the math by hand, the project allows us to use Excel to do the math in Excel. So you can do this activity and also the project at the same time, and you will also learn how to use Excel to do the math and all the rounding and right answers in any kind of form required, since Excel can give you all of these options. So after you are done, then I will demonstrate how in Excel I can use the calculator feature of Excel to answer the questions here. So you want to pause the video and try to fill in the table. So I have filled out the table, and also I have done question 4 of my project that asked me to do some histograms, but in order for me to do the histograms, I needed to have completed the table here. Now, if I want to find the number of players with heights less than 65.95, that would be these categories of height up to 65.94, and the number of players will be the sum of frequencies, because the frequencies indicate the number of players. So I should do 15 plus 3 plus 5. And in Excel, this can be done quickly if here I say, so let's assume these are the categories, and I will be adding in this column D. So here, if I want to find the number of heights less than 65.95, I will add with the sum function from 5 to 15. And the answer will be 23. So 23 is the answer to that. 5 plus 3 plus 15, the answer is 23. What's the percent of players from 67.95 to 71.94? So 67.95 to 71.94, and they are asking us for percentages. So I will be adding relative frequencies. So I have to add 17% and 12%. Now, we described that in the project video as well. Because it happens that the sum of the frequencies is 100, the relative frequencies as percentages agree exactly with the frequencies as numbers, the values. This is not true, and it's only true in this example because the sum of the frequencies happens to be 100. We surveyed 100 individuals, 100 units from the population. So this is very unusual, and it's not always true that the relative frequency numerically will agree with the frequency. Now again in Excel, to do that, I'm going to add, I think from 67 to 7194, the percent of athletes, which is relative frequencies, and that will be 29%. The percents of players from 67.95 to 73.94, and again this is percent of players. So looking at relative frequencies, 67 to 73.94, that will be from here to there, and relative frequencies will be from 17 to plus 12 plus 7. And again, I will go in Excel to do that, equals the sum of, and I'm going to highlight 17 to 7, and it's going to add for me, and the answer is 36%. Also, another way of finding it would have been to take the 29% we have already added and then add 7% to it, which is the third category. The percent of players with heights at least 65.95, at least means equal or more or greater than, so the least it could be is 65.95, and at least 65.95 means this category and all the larger categories, and that's the percent of players. So I'm going to go here 40, and then I'm going to add or everything below it. So again, I will do that in Excel because it's much easier, equals the sum of, and I will highlight 40 to 1% and close it, and this will be 77%. So this is 77%. And how did I find it? I did 40% plus 17 plus 12 plus 7 plus 1. And then the number of players in the sample from 61.95 to 71.94. This is the number of players that will require that I add frequencies from 61.95 to 71.94. That will include this group of frequencies that I will add. And in my Excel, equals the sum of, and I will add from 61.95 to 71.94, and that will be 87 of the 100 players.